Okay, welcome to the next talk, which is OT and SCADA security by Vladan.
Thank you very much. Okay, thank you everyone. So there is much more people than I actually expected. So what's wrong with you? Why you don't go there and watch the guy blowing stuff up? So it's chemistry, and to be honest, we will be going to blow stuff up because SCADA and OT can be really scary from time to time. So, and we will talk at length today, so I don't know, I think we have 30 minutes for all of this, so I will leave a few minutes for the questions at the end. So let me first introduce myself. So my name is Vladan Nikolic, I'm local from Serbia, I work for IBM. I lead IBM X-Force Red penetration testing team for Europe. So that's my daily job, but all the other time that I have, I'm retro computing fan and I like to tinker with hardware. And by education, I am an engineer for power distribution systems. So, and that was my first touch with SCADA in power distribution systems. And it was really interesting experience. And this is what we are going to talk today. So we are going first to cover a bit of topic about ICS, so in general, so to make sure that we all have the good idea, because there will be a lot of abbreviations is used in this area. Then we'll cover some of the most common parts of architecture and organization of SCADA and the ICS networks in general. Then we'll cover a little bit about how to actually test the SCADA, how to perform pen test in SCADA and try not to blow yourself up. And of course, at the end, I will leave a horror story. I had time only for one horror story from one of our penetration testing done at the customers a few years ago. So I mentioned that first thing to cover is actually abbreviations, because you encounter them in a daily word. So first one that I want is, what is actually OT? So those are operational technologies. What does this mean? It's a very broad term, which can, if you apply it very widely, it can take anything. Your car system, your smart home, which is now called IoT, because it's a little bit different than these technologies, but generally, by nomenclature, it can go under this area also. ICS is a little bit more narrow term, which means integrated hardware and software designed to monitor and control industrial processes. Keyword here is industrial processes. So SCADA, as a last term, is a system which actually do real-time monitoring of the processes. So how did we came to have SCADA? So long time ago, since very early days of humankind, we started brewing beer. Okay? And if you try that at home, you know that there are few things that you need to take care very carefully. So that is a pressure, that is a temperature, you need to measure how much bubbles are there. And in every single process, in brewing, in distilling rakia, we had this. And of course, people found also this useful in some other areas like oil. So in oil refineries, where we have processes which are used to separate crude oil into different derivatives, and they need to be controlled really tightly. So in order to do that, it is quite difficult to do it by hand. While you're brewing beer, it's just 2 or 3 parameters, and they're not so critical. If you have enough time, you can do it manually. But in some bigger and more sensitive processes, it can be really difficult, and in some cases even dangerous, because if your temperature goes over some threshold, or your pressure goes over some threshold, there can be a big boom that you will not like for sure. So in order to control such processes, we have deployed different components which are doing just that. So I will start from the lowest, and they are not on this screen, but lowest are actually actuators and sensors. So those are the analog valves and the measuring devices which are used to collect the data from the process itself and to actually manipulate the process itself. So for example, you can have electric valve which will close under some circumstances. You can have measurements for temperature, for salinity, for acidity, for different parameters that are important for your process. And in the past, as I said, it is not possible to control all of this by hand, so we have decided to connect them to some devices which can be programmed in different ways. In early days, it was analog devices, so you have comparator. So if temperature from my sensor goes up, so voltage will go up, my comparator will trigger and close the valve, or open the valve, depending on the process. And as time goes, it was more and more automated, and we started using a bit smarter devices, which are called programmable logic controllers, or PLCs, and remote terminal units, RTUs. So they are usually connected very low in the network diagram and directly communicate with actuators and sensors in order to collect the data and even act on data. For example, PLCs can be programmed in very simple language called ladder, which is best described as simple if, then, else. So if pressure is over the limit, close the valve and run away. So, of course, after some time, we started adding more and more smart devices into the network. And the big revolution came in the last 20 years when somebody decided why we are using 48 volts or 25 volts analog lines to communicate when we have Ethernet everywhere. And somebody smart decided, oh, let us put Ethernet on these devices. And big problem is that Ethernet on these devices are just afterthought. So it is just added on the one side, usually on PLCs or RTUs. It's added, but protocols remain the same. So you still have the same protocols like Modbus, which is very simple and very old protocol. It is just now Modbus over IP. So no security features have been added onto this protocol, because when it was analog and not connected, it was simple. So you just need to prevent bad guys to come close to your devices, and they are safe because they need to go and to manually change something in your network in order to have impact. But with proliferation of Ethernet and unfortunately Internet, it becomes much more fun. Why it become fun? So here is old architecture. So we had OfficeNet when our people sit down, reading their email, accessing their internet, having all day-to-day fun. And we have system admins which rule their realm, implementing malware system, anti-malware system, implementing patches, configuration changes. So they will taking care of OfficeNet the best way possible. Of course, we know that it doesn't work that way, but in ideal world, yes, they were ruling their northern realm with no problems. On the other hand, we had separate realm with ICS devices, in which there was no system admins. There were electrical engineers, which have no idea about computers, and they do not care about computers. They have their wires, they have their comparators, operators, they have their PLCs, RTUs, and they don't have a problem and concept of malware, of missing patches, of installing antivirus on their device, because they don't need it. They need just to put big, strong guy on the door and prevent anybody from entering the machine room, and they are safe, no problem at all. But unfortunately, since SCADA, or actually since ICS, devices are there to support the business, and business guys sit in office network, and they have very, very, very bad ideas and wide ideas to make some money out of everything. So they say, oh, but we want to see stuff that happens in our distribution network. So why we don't have this? So I want to be able to see how processes, how much we manufacture. So people had to create some interconnection between OfficeNet and ICS, formerly isolated network. So at this point, interesting stuff starts to happen. So first, we start having, as I mentioned, IP network inside ICS network. Ideally, again, I'm showing you ideal situation, and we actually have this separation between OfficeNet and ICS. And only very limited number of services are allowed to communicate between themselves, because in ideal world, we have Historian. Historian is a system which collects all the data from our ICS devices and put them so they can be retrieved and verified and monitored. You can create nice graphs for reporting or for whatever, but it is just that. So data comes from the ICS to Historian, and from Historian it is distributed into the OfficeNet. Still safe, not the best idea, but still safe. Op. And on the other hand, people want to control their SCADA. So you are all aware of concept of smart grid. I will touch that in more detail later. But smart grid actually not just communicates data from the grid, but actually can impact the grid based on business rules. So that is actually the smart grid. So, and then we have implemented some application server which collects some information from SAP systems or from any control system inside our Office network and pass this information into the ICS network. And that is where all the trouble starts. And of course, in some cases, in reality, this DMZ is not existent, and this separation is actually non-existent. And when you go to the customer to do the pen test on their internal network, you suddenly see port 902 open with all the fun. It's Modbus. So why we have ICS devices in the OfficeNet, nobody knows, but they are there. So, as I mentioned, as SCADA controls processes, these processes can be quite sensitive to manipulation and operation parameters. So it is what kind of systems, what kind of enterprises using SCADA. So it is manufacturing, it is power distribution, power generation, nuclear power plants. It is water treatment, it is, how it's called, so manufacturing of different goods. So anything that has manufactured, so oil and gas also, refineries, oil rigs. So everything is controlled by SCADA. And what is the problem? When you are doing testing, if there is any impact on manufacturing process, as I mentioned, it can be really, really bad. So I had opportunity when I was on faculty, I had opportunity to actually see what happens if change happens which is not planned. So we were visiting this power station when somebody did a big mistake. You know, in power distribution, you have a large currents and large voltages. And in order to disconnect power lines, which are transferring this huge amount of energy, it's not enough to have simple power switch like you have for your lights. So it needs to be a big beefy switch which has oil inside of it in order to extinguish the arc, because arc will be huge. What happened here? So if you want to do maintenance on such switch, you need to make sure that switch is not under the voltage, of course. So you need first to use the switch to open, to disrupt the current, and then you have separators which are much simpler switches, which more resemble of our power switches for the light. They are much bigger, of course, because they handle 400 kilovolts. And then you open those, but they do not have a chamber to distinguish the arc. And usually there is a lot of procedures that you need to ensure that when you go to manipulate separator, there is no current flowing through that separator. In this case, what happened? Because they were using 3 knife-based, and one of knives remained connected. And when they, on the switch, when they opened separator, it went boom. So explosion was so big that one of the walls was just compressed out of place and squished the office behind it. So playing with SCADA can be really dangerous, and it can disrupt critical operation. Of course, there are places when there will be no such a big impact. I had opportunity to go to do one pen test, and before us, there was a company which did pen test on SCADA, but there was a company who did just normal pen test. They caused disruption. They costed $4 million. No dead people, but just big damage to the company. And of course, SCADA systems are complex. As I mentioned, they are using different kind of technologies, different kind of protocols. Many of those protocols are not known to IT people because they come from old time of analog communications. And of course, safety concerns, as I already mentioned, it can be quite dangerous, not just to interrupt the business, but to cause serious harm, so stuff can blow up and endanger everybody around yourself. So how we actually do the pen test in such environment? Of course, you already have idea that red teaming might be really stupid idea in such environment, but hey, people are attempting to do that. So as you see here, so most of the steps are more or less similar, like on the standard pen test. So first step is to make good planning and to do passive reconnaissance, that you also do on normal pen test. Active reconnaissance and scanning, that we do on the normal pen test. Gaining access, maintaining access, analyzing, reporting. So all steps that we normally do in any pen test. So what's the difference? Big difference is during the normal pen test, most of your time is devoted to point number 2. You're actively searching for vulnerable systems. You do a lot of stuff like injecting packets, sniffing, creating a lot of SIM packets, scanning open ports, searching for something that you can exploit. If something goes down, it goes down. So yeah, it's Windows service, just restart the service and no harm there. In the SCADA, as I mentioned, that would not be acceptable, not just because of the damage, but because also of regulations. Because some regulations say, for example, that you cannot lose connectivity to your CCTV systems which monitors environment for more than 2 seconds or something like that. So you need to have this. So this is for airports specifically. They need to have surveillance systems always active in sensitive areas, security sensitive areas. So in SCADA, so we cannot do active reconnaissance and scanning like we normally do in standard pen tests. But we focus and spend about 90 to 95% of our time into step number 1. So planning and passive reconnaissance. What is the difference between passive and active reconnaissance? Anybody? Yep. So during the passive reconnaissance, we do not inject a single packet into the target network, because at that point we have no idea what's running in that network, how dangerous it is. So we usually do it like cooperation between the client and us. So if client has plans for their SCADA environment, they can share it with us. If they have any ideas about their SCADA environment, they share it with us. Problem is that many customers do not have any idea what is happening in their SCADA network because they are not operated by them. So when you buy SCADA, you actually do not control it. So you buy SCADA from some big vendor like Siemens or anybody else, and you do not get components to implement. So there is a vendor who will come to you, they will do all the setup for you, you tell them what you want, what you need, they will connect everything, they will program everything, and they will tell you, don't touch it, we guarantee operations only as you do not touch it. So forget about installing antivirus, about installing patches, nothing is allowed. Second thing is that vendor usually has some form of remote capability to connect to SCADA so they can operate it for you, so they can fix it, implement any changes that are necessary for the process. So that also can expose SCADA network to the internet. So if you have some VPN somewhere that will end up in some of ICS network, that opens up. So if you have VPN which is coming from vulnerable appliance, then you can have a serious problem there. But as I said, so first thing is that customers do not know about their SCADA in 90% of the cases. So first thing is we need to do inventory for them. How we do that? By using passive approach. So we ask customer, okay, so we have your high-level network diagram, so we have good idea where are your switches, where are your routers, firewalls, and then we try to create span ports. Span ports are layer 2 networks which will mirror packets from different switches into few points where we will be connecting our devices which will capture this traffic. And we will let it run for like week or month, depending how time we have and how network is active, how they commence their business. So there are usually some waves or depending on the process. So some processes are quite quick, so we can have results in a few days. Some processes can be slow, and it can take weeks before we have something. So, but we will let it run and collect a lot of data. And then we need to analyze this data. So for this, we are using different tools. So first, and the most used tool is Wireshark. So we like it very much because it is really good and it will do the job properly. So you can analyze unknown networks and see what is inside. But of course, if you collect data for a month, you have a huge number of packets, which is quite difficult to analyze manually. So the first thing that we did was Project Bandolier. So it is, I think, company is called Byte Bandit, so don't get me on that. So they developed signatures for Snort. Snort was open source IPS system before Cisco bought it. And what we did, so we would be loading these Bandolier rules into the Snort and then just replay the traffic. And Snort will do everything. So it will go through packets, it will recognize signatures of protocols that are interesting for us, important for us, and it will create a log that we will use to analyze what is inside the network. And that was actually pretty effective, but problem is that every time you do that, you need to go and manually verify what is not recognized, because there are new protocols, there are old protocols implemented in some weird way or running on some unexpected transport protocol. So there are a lot of stuff that's still required to do manually. So then we started developing our own signatures from Bandolier. Then we started using our own Python scripts and creating different analysis tools. But in the end, we would have good inventory. So because all ICS smart devices are using IP in the end. So we would have at least list of all IP addresses, and we would see which ports communicate. So we might not be aware of what is the service on that port, but we can know what is active. And with this knowledge, we already know where are the dangerous parts and where are better parts. And then we can go and use what I have on this slide as some regular pen testing tools. And with 3 big asterisks, because it is quite sensitive thing. So we cannot run every tool. So if you go into the SCADA environment and run Nessus, it will be disaster. Why? So because these devices are small. They have small microprocessors on them. They are usually not full-blown Windows machines. So they have small microcontrollers which have very fragile TCP/IP stack. So they are not made to handle big number of connections like your regular PC. So, and usually on this stack, they have no opportunities to implement any kind of encryption also, because they are small devices. And they need to respond quite quickly. They do not have time. Do you accept this certificate? Yes or no? And in order to do this, so they are small. And if you create few embryonic connections on a single device, so just sends in packets without acknowledging it, in the end, device will crash. And if this device is important, like controlling lights on the landing strip of the airport, it is a lot of fun. So you need to use the tools very smartly. So Nmap is heavily used, of course, but it is there is a smart way to use it. Not fire it on everything, but when you collected this data passively, you have a good idea, oh, this is Windows machine. And if it is Windows machine or PC machine, you know that it is more resilient and you can do something to it. Not everything, but something, because there is software running on it which might not handle stuff very well. But if you see that there is no Windows, it is just some embedded device, then you really need to be careful. So the next thing that we use is usually SNMP protocol. So SNMP is quite safe, but still needs to be used carefully not to overload these devices. So using SNMP to collect additional information about devices helps really much. So what we could not get from the Traffic captures, we might get with SNMP and get more details about device. And with these two things, we can create pretty well covered list of endpoints and know what's run on them and what we can do. Then we will see, okay, this is just a website. Okay, on website, we can do some stuff fairly safely because it's web stuff. On some devices, we will not touch because we see that it is Profibus, DNP3, or any other protocol. So we can do stuff that is specific for the protocol in order to verify if there is any form of encryption. There is not. If there is some form of authentication, again, there is not. So we could do such stuff and check. And if it is non-production, so we had from time to time opportunity to work in non-production environment. So for example, in refineries, they have downtime when they clean everything. So it is like 2 or 3 months when they do not produce anything. And that is opportunity for us to go and to actually perform check on those fragile devices. Because at that point, if they crash, they crash. They do not control process actively. So we can do some checks. And what are the most common things that we discover in such engagements? They are legacy systems, as I mentioned, so they have very heavily outdated operating systems. So even if there is a Windows, it is not surprising to find Windows NT or Windows 2000. Windows 2003 is already a very advanced system. So of course, nothing is patched. There is no antivirus, as I mentioned, because it's not allowed to install patches. It is not allowed to install antivirus. It's not allowed to upgrade your operating system. And unfortunately, there is not much Linuxes. Linuxes are usually on the embedded side of the story. But on most of the controlling applications are running on Windows. So, and as I already mentioned, there is a lack of encryption because small devices lack processing power to do any meaningful encryption and to protect the data that goes. So it is very easy to tamper with those data, to inject packets, to manipulate those packets, and to do whatever you want to do because there is no endpoint authentication, there is no any checks. And of course, my favorite, default credentials. So because as I mentioned, vendors are not giving you opportunity to configure your own network. They will do it for you. And they do it not just for you, but for 50 other companies in the region. And they do not have capability to remember passwords for hundreds of devices on 50 different customers. So they just use defaults because that's easy. You don't need to remember anything. And then you just go and try any default credential and you will be in 95% of the cases. It's very rare that any passwords are changed. So what we can do to help customers? So yeah, there are a few best practices we can suggest. Of course, most of them will not be followed because there is a big problem, as I mentioned. ICS world is ruled by engineers. They do not have concept of security policies. They do not care about that. They do not have concepts of any IT because they are not computer scientists. They are just engineers. And it's always, whenever we speak with customers, we see this fight between ICS guys and IT guys about, oh, policies do not apply to us. Yes, policies do apply to you. No, they do not. So always fun. So even if they implement some security changes, ICS guys are known to bypass them. So we saw a situation in which there was air-gapped network. ICS was air-gapped. And they were very proud of that. But what they do, so they have a laptop, they connect it to their office network, collect what they need to collect, so patches, updates, firmwares, then take their laptop, bring it into the ICS network, connect it there, do the maintenance they need to do, so bring up every worm, every malware that they picked up in office network, on internet or whatever, and just run it inside ICS. And then we have Stuxnet, yeah. So, as I said, it is quite good idea to isolate SCADA networks. There are now devices from many manufacturers which offer specific firewalls and IPS systems which can be used in ICS network. So they do understand Modbus, FNMP, all the protocols that are used in the network. I know Palo Alto is manufacturing them. I know there was Italian company, I forgot its name. So there are many of them who are just adjusted for such environments. So they are big ruggedized devices which can endure all the requirements of industrial deployment. and they can do this. If they cannot prevent, they can detect. And you can go to such level, okay, if Modbus protocol is used, and if you see listen all command, block that command. Because listen all command will make sure that every device connected to Modbus will stop responding to any other commands. It will just stop responding. So it will listen, but not do anything else. And it is quite effective way to do denial of service in Modbus. And of course, monitoring is quite important. Strong authentication, I cannot stress much, but to be honest, I never saw SCADA network with strong authentication so far. But yeah, we can hope for. So this is one of the horror stories. So we are at the time, so can we continue? Okay. Okay, so we had opportunity to test deployment of smart meters at customer wanted to deploy smart meters to their industrial clients. Smart meters have been specific for industries because you have multiple places when you need to monitor consumption, and then they have gateway device deployed which will communicate with every single smart meter, collect the data from those smart meters, and send them to the AMI head end together. So it simplifies communication. So first thing was smart meters. So they had so heavy protection, like using standard cylinder lock to prevent everybody to go in. So we just broke the lock and we were in, so that was kind of easy. Then we continued to concentrator. Concentrator was much more interesting because it was a device which had wireless communication among others. So UMTS modem, power supply, Ethernet port, everything was accessible. And when we opened the device, we discovered there is a 16 gigabytes compact flash card which contained all the Linux operating system in it. So we have disassembled this device, picked up this card, and analyzed content of it, which was quite simple. Then we discovered that it is all unencrypted and we can easily modify files on the compact flash, and we connected via SSH by just resetting password for the root user, because yeah, we are in control of password file. That was all nice, but even some of the data that we found on this device was encrypted and double encrypted, so I will not go into much detail, but it was all fun, so in which we had to debug some of the executables that we have discovered on the compact flash card in order to collect, to find out where are the keys. And we managed to find a CBC key which was used for encryption and to encrypt the data, just to discover that software is also encrypting the data, yay. So we get back to it and decided we will not go to, again, to try to crack this password, but since we control flash system, we just modified files and said, oh, you don't use encryption anymore. And as a result of that, we gained access to certificates and private keys, which enabled us to access AMI head end. So we practically were able to go beyond the firewall of the company which is using meters to distribute electricity. So it gave us full access to the AMI head end. Okay, so that was all from my side. So any questions?
Thank you. So you've mentioned industrial firewalls.
Yep.
And they've got an interesting feature where, because of course safety is more important than security, and of course business is more important than security. If the firewall fails, they fail closed. So in other words, they physically connect their input and output. Were you ever maybe able to exploit this feature in order to bypass the firewall?
For denial of service, if that is your point, it's quite easy. So I didn't do it on industrial network because denial of service is usually not the main goal here, because we know it's quite easy to do denial of service. As I mentioned, everything is quite weak inside and it's easy. But we did something similar on IT level. So you have IPS devices, for example, in general terms, which should be able to do a lot of stuff. But if you just overload their CPU, they have two choices: either to pass traffic uninspected or to drop all the traffic. And in the past, we have encountered both. So with like 5 megabits per second, we were able to kill devices which should be able to handle many gigabits of traffic. And if they were configured right way, we were able to bypass any kind of inspection on those devices and completely own the company. Of course, in SCADA network, it's a little bit different, so they fail close, so they will be just denial of service, but I assume that will be the same principle.
Yeah, thanks. And another question, you've said at one point, in the end, everything is IP. But in fact, a lot of SCADA people used to say like, no, encapsulation is too much for us. We're just going to run on top of Ethernet and ignore all the higher levels. So have you ever encountered something like that?
Yes, it's not uncommon. So we saw very imaginative solutions from SCADA people how to do stuff. So they would try to do everything they could, of course, because it's not safe to use IP, and I agree to some areas. But what we saw, for example, in one customer, they were doing combination. So in field sites, they had IP. But on central site, to communicate with field site, they were using only serial. And they had multiplexers, and then they would connect to one field site, collect the data. A second field site, collect the data over the serial line. But what was the problem? So we were doing analysis, and we discovered that they have exactly the same IP range in every single field site. It's easier for them to know what is what. So they don't need to have 15 different IP setups. So they have one IP setup, which they replicated to all of their sites, and they connect serially to every single site and pick up the data, and they go, oh, we know which site it was, and we know IP address, we know exactly which device it is. So they would do many stuff. So as I said, there is always a fight between SCADA people and IT people about everything. So, but most of the modern deployments, they are being pushed to IP because in the end, business owns SCADA. And business want new solutions, cheap solutions, and I don't know if they can have new solutions without IP. To be honest, all new deployments are IP-based.
Thank you for your presentation. I would like to ask you about the active scanning when you perform some active scan or active reconnaissance on SCADA. Do you have some experience that maybe, or do you have experience with problems that can occur when for example, with Nmap?
Yeah.
Is there a big noise?
No. So as I said, we do our best. We do our best to avoid problems. So this is why we do heavy reconnaissance. Very heavy reconnaissance, and we work actively with client to make sure that we know everything that can go wrong.
With regular monitoring?
Sorry?
With ongoing monitoring?
Yes, everything. So we work with customers. So this is cooperative task always, because it is dangerous. So we generally, it is not allowed for my team to do active testing on production SCADA. It's forbidden. It is usually done only in non-production. In some specific cases, we have requests from customer, but we really want you to do that. Okay, yes, but there are some prerequisites that we need. So we need for you to share us every single network diagram, every single information that you have, and we need you to work with us. So we will start discovering, we will ask you, what is this? And you need to tell us what is this. And you tell us, oh, we have no idea what is it, then we will go physically to device, inspect it, and say, oh, we know what is this and how to handle it. Problem is, as I said, these devices are very fragile. Even simple Nmap scan can can crash the TCP/IP stack on these devices. So we saw like 5 consecutive connections, more than enough to kill the device. I believe there is even more sensitive devices. So what we usually do, even if we have to do such wide scanning, but we avoid that, so we always try to do targeting scanning. So we saw that ports are open, we know that ports are open from the passive reconnaissance, and we just want to do some fine tuning or mapping. So we try first to use SNMP if possible. They are using public-private, so it's quite easy. So we collect as much information as we can, but in some cases it's not possible, and then we will just use full TCP connect to one single port to see what's happening. Or we will do it manually using telnet.
Port by port.
Yeah, so it is very, very, very limited, targeted, and we always have customer with us, and we discuss what is the risk if this device becomes unresponsive. If risk is, it's not important, we might do it. If risk is high, we will not do it. We will ask, okay, can you give us this device in non-production environment, and we will check device it on itself.
Thank you.
Anybody else? This nice boy in blue shirt.
Thank you for wonderful presentation.
Thank you very much.
What about applications?
Yes?
Because you were mentioning a lot of PLCs and this stuff. We also know there are applications.
Yes.
How about them?
Yes, they are there. Absolutely. So yeah, it all depends which kind of applications. So if they are SCADA applications, so like S7 or something like that, it can be tricky because they can lose connectivity to control the devices, and that can be dangerous. If they are simple web applications related to historian or librarian or some supporting function, HMI, so anything that even if it is crashing, if it crashes, is not directly impacting the production, we can do stuff like application test in such cases. Source code analysis, yes, of course. So anything that is passive, we can do freely. So source code analysis, running binaries in isolated environments, searching for 0 days. So that's not a problem. So there are lots of web services inside this because most of PLCs have some kind of web interface for God knows what reason.
So I'm wondering, because DOS is like a big threat in such environments, or in many environments. Like it's easy to achieve, and it has a huge impact. So we try to not touch too much, but the threat is real. I mean,
yeah.
So what do you think about that?
Yes, so I had a friend who worked in a big bank, and he was head of business continuity in that bank. And I spoke with him, asked him, do you have any BCP exercises? No. Why not? Do you want to know that your plan is working? No, because I like my job. So if I do BCP exercises, and if stuff goes wrong, I will cause downtime for the bank with no reason at all. So it's better for me not to do it, and if it happens, it happens. We will try our plans. They might work, they might not work, but I will not be guilty of that. So that's the approach. So you don't want to cause more problem than you should cause for anything. So denial of service is really dangerous. So this is why we make sure to analyze all the vulnerabilities or other issues that can lead to denial of service. So yes, do you have firewall? Yes or no? Do you have separation of network? How you interface between ICS and IT networks? So do you reuse some parts of infrastructure? VPNs, remote connectivity. How do you handle, do you have separate laptop for ICS environment, or you share the laptops for both environments? So we make sure to analyze such prerequisites for denial of service to try to minimize it. That's what we can do pretty safely. But testing, I know if I just run Nmap, I will kill everything. NAS is even better.
Thanks for the talk. I have one comment and one question. Comment is, I had 2 energy suppliers, so they really wanted to have the vulnerability scanning tests.
Nice.
So it worked with Nessus if you have custom scanning profiles where you really throttle down the connections. But of course, as you said, it's the best if you can have some demo devices and just test it there. So, but the question is, you said that most of your customers are not allowed to really manage the OT networks because the suppliers are doing it.
Yep.
So, but they are coming to you and getting the results from you. How is the remediation? Are they then going back to suppliers and suppliers are completely fixing it, or? But what's the sense of testing it then, right?
They need to be aware of risk. So there are some compensation controls that they can implement to contain the risk. So they will, of course, go to vendor and ask, oh, we have this report done by IBM. So can you please try to implement at least something from this? Also, let us at least change the passwords, for the love of God. Of course, they say, no. So in that case, what they can do, so they will act on monitoring. So they will set up monitoring. They can set up stuff like device discovery. They can set up some firewalls, IPSs, which will reduce chance of somebody actually getting into position to misuse this issue that they have. So compensation controls, that's the key. Nobody else? Again, you use your bonus. You need to pay beer.
Another question.
Why?
What would you prefer? Purdue, let's say, redesign or data diodes for separation? It's a trick question. Like paramodel or data diodes? What would you prefer?
I don't like data diodes, personally.
Nobody does.
Yeah. So redesign. It's expensive, but I think in the long run, it will give more sustainable results. Did I answer right? There's no right and wrong. Okay, anybody else, or I'm free? Yay. Thank you all. And if you have any more questions, I will be around